Hey guys, Mr. Herc here, and today we're going to be going over AP Pre-Calc Lesson 3.14. Let's get right into it. So pause the video now if you haven't done the 3-peat G yet, because I am about to go over the answers. So number one, we have that this is a quadratic function because the second differences are the same. Find the value of n that this works. So here we see that this is all spaced one apart, so we don't have to do anything there. And then for this one, we see plus 1, minus 1, we don't know, and then plus 7, or sorry, minus 7. This should be minus 7. So continuing this from plus 1 to negative 1, that's a jump of minus 2. So that is what these jumps should be as well. So negative 1 minus 2 is negative 3. And so from 2 to n, we got to subtract 3, so this should be minus 1, and then that's minus 5, and then minus 2, where these are all the same. So we get n to be negative 1, so B is going to be our answer there. Number 2, what is the intersection point between these two equations? So just set them equal to each other and solve for x. So one, we want to get the same base. So we can leave that left side kind of as is for now and rewrite 25 as 5 squared, where we get a base of 5 to match that base of 5. Then we want to rewrite this 5 to the power of 3x plus 2 equals 5 to the power of 2x. Remember, if we have two bases that are the same, we can set the exponents just directly equal to each other, and then subtract, and then solve. X should be negative 2. There are no domain restrictions. Those really only come when you take the log of a negative number. And so right now we're not doing that, so no domain restrictions, so negative 2 works just fine. All right, number 3, the function is given by sine pi over 2x minus 1. Which of the following could be the graph? So first off, we kind of want to see where our midlines are. So we have one here, one there at negative 1, at negative 1. This midline's at positive 1, so we can eliminate A because it should be negative 1 here. We also want our amplitude to be 3. So our amplitude is 3 here and 3 here. It unfortunately is only 1 there, so we have to eliminate B. And then we want to figure out what is our period. So our period is 2 pi over our B value, pi over 2. This is equal to 2 pi times the reciprocal, which should just be 4. And so 4 should be our period. This actually matches both, so that doesn't help us. And then we have a sine function with no horizontal translation, which means right at the y-axis, it should be starting at the midline going up. So C is going to be our answer for 3. All right, so today we're going to be talking about graphing polar functions. So now that we have learned how to explore polar coordinates and how they work, it's only natural that we begin to explore the concepts of actually graphing them. And so polar functions, like we talked about, are basically equations that were given where we have an independent variable, which is going to be our x or theta, and then our y variable, which is our r. So theta and r is what you will see when we're dealing with polar coordinates. All right, and so the wording is pretty simple for the AP exam. The graph of the polar function r equals f of theta, where f of theta equals whatever equation is shown in the polar coordinate system, and then it will typically give you a domain as well. Just be aware of the lingo and language they use, but there's nothing new that you really need to remember from this slide. All right, so how can we actually graph polar functions? It's pretty simple. You just want to create a table of values. Is always a good strategy when attempting to graph a new or unknown function. Here we're going to be creating a trig table of values, right, using values that are nice for trig angles such as pi over 6 and pi over 2 and pi, instead of like 1, 2, and 3, plugging it in. This topic is interesting because it will only appear on multiple choice questions, and typically you'll see two different types of questions. The first one is they'll give you an equation and ask you to match it to one of four graphs, and the next one is they give you a graph and ask you what equation is this. And so all you need to do is just use process of elimination and a little bit of guess and check to plug in values to really just determine which answer is correct. So first, let's review real easy values to plug in using our unit circle. And you will see why we did this in about 5 minutes. So sine of 0 degrees is going to be 0. Cosine of 0 degrees is 1. Sine of pi over 6 is 1/2. That's also the same for cosine pi over 3. Sine pi over 2 right here, this is 1, and cosine is 0. You'll see why we did this in about a few minutes though. And so first off, before we begin, let's start by graphing this thing. So this function, we have 3 minus 3 sine theta. All right, and we're graphing it from 0 to 2 pi. So I want you to take some time, pause the video now if you're watching this because you're not in class, and find the decimal approximations when you plug 0 in for theta, or when you plug pi over 6 in for theta. Pause the video now. All right, so I'm just gonna write down the answers that I got using my calculator. So 3, 1.5, 0.8787, 0.4019, 0, 0.4019, 0.8787, 1.5, 3, 4.5, 5.1213, 5.5981, 6, 5.5981, 5.1213, 4.5, and then 3. So if we plot this, we start at 3, and then we have 6 there. At 2 pi, we have 3. At pi, we have 3, which should be, let's see, 2, yeah, somewhere right here. And then this is pretty much how the shape is going to look. It's going to basically be a heart shape. Not a perfect heart, but very similar to a heart shape is what you get when you graph it. All right, so that is how we graph a polar function. Now let's just actually get into solving these questions. So here we have a figure that shows a graph. Which of the following could be an expression for f of theta? So what I like to do first is kind of see what values could we plug in that would be smart, right? And so let's start by plugging in 0. 0 is always a nice number to plug in. So if we plug in 0 here, you should get sine of 0 is 0. So 2 plus 4 times 0 is just 2 here. If we do this, 2 minus 4 times 0, this is just 2. This is 2 plus 4 times 1. Cosine of 0 is 1, so this would be 6. And then 2 minus 4 cosine theta, this would be negative 2. And so taking a look at this, at 0 degrees, this lies directly on it. It is at 2, and so 2 should be our answer. So we can eliminate C and D from that. Now let's take a look at what other options or what other angles can we plug in that would be smart that we could use to kind of help us here. And so we could actually plug in pi over 2, right? So taking a look, I look at 90 degrees. I don't see anything here, which means we must get a negative angle measure, and we don't know if it's going to be this or this. So let's just plug it in and see. 2 plus 4 sine pi over 2, and then 2 minus 4 sine pi over 2. Right, and so I'm only testing out A and B because we eliminated C and D. Once we do this, sine of pi over 2, this is just 1. So this would be 2 plus 4, which is 6. And this is 2 minus 4, which is negative 2. We are looking for a negative 1. So B should be our correct answer. A would be incorrect because there is no point that is pi over 2 comma 6. So that is kind of our problem there. Right? Let's move on now. Example number 3, we have the graph of the polar function r equals f of theta. Which of the following could be an expression for f of theta? So let's start by just plugging in 0. So this would be, if we plug in 0, 3 times sine of 0, which is 0. This is negative 3 times sine of 0, which is 0. This is 3 cosine of 0, which is 3 times cosine, which is 3. And then this is 3 times cosine of 0, which is negative 3 times cosine 0, which is just still negative 3. We can eliminate C and D because if we take a look at 0, the only point that's on it is at 0. There's no 3 here, and there's no negative 3 here, so we can eliminate C and D as potential options for us and narrow it down to A and B. Now taking a look here, what value could we plug in? We could try to plug in, let's say, pi over 2, right? Let's see what happens when it's pi over 2. We should get, as a result, the only dot that's on this line is at negative 3. So that's what we should get when we plug in pi over 2. So 3 sine 3 times pi over 2 is our A. And then for B, if we test it out, negative 3 sine 3 times pi over 2. Sine of 3 pi over 2 is negative 1, so this should be 3 times negative 1. And this would be negative 3 times negative 1, which would be 3. And negative 3, we want negative 3 as our answer. And so we are going to circle A as our correct answer for this one. All right. Now, this is something that you will be quizzed over, and it could help you narrow down some of these graphs pretty quickly. If we have any function, right, whether it's A cosine n or A sine n, a better example is if we have like 2 cosine 3x, where this is n theta, sorry, or we have 2 sine 3x, right? We only want to look at that number that's on the inside of the sine or cosine function. If that number is odd, then the number of petals the rose curve will have will be just that number. So in this case, what is n going to be? N is going to be 5. Now in this one, if n is an even number, right? Let's say we have 5 sine 5x. We're going to have 10 petals, which is 5 times 2. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So here n would be 4. So this could be like r equals 10 cosine 4 theta. Could be like an example equation of this graph right here. Right? So this is just one rule to go or to remember. It will be on your next quiz. It's pretty easy. The easiest way to remember it is just remember 1 is an odd number, so you multiply whatever the number is, if it's odd, by 1, the odd number. 2 is an even number, so if n is even, you multiply it by another even number, which is 2. So here, it might be hard to see, but we have the function 3 sine 4 theta. Which of the following is a graph from 0 to 2 pi? So we have n here as 4. And so if it's an even number, you double it to get 8 petals. So this one has 4 petals, 4 petals, 3 petals, and 8 petals. So we can narrow it down to C without even testing a single value. All right. So there will be a question just like this on your quiz. Pretty easy as long as you know the rule. All right. Number 5. We have 3 cosine 3 theta, and so right now n is odd, so it should have 3 petals. Unfortunately, all 3 of these have 3 petals, so that kind of sucks for us. Let's plug in a nice number though. Let's plug in 0 and see what we get. So 3 cosine of 3 times 0 degrees. This is 3 cosine of 0 degrees. Cosine of 0 degrees is 1. So 3 times 1, so 3. So we should get the angle, or the coordinate 0, comma 3 on the grid. The only one that applies to is B, so that is how we know B is our correct answer for example 5. So if you have any questions, please come see me in office hours. I will be willing to help you guys, and I will see you guys later. Peace.